Good day, ladies and gentlemen. This is Sarel van Gr12, aka Mr. VG, and I am now on my second last video of this series in exam preparation, looking at the November 2021 Department of Basic Education Maths Paper 2. When we look at this, it's going to be a relatively short video because it is actually a theory sum. So ladies and gents, buckle up. Please make sure that you can do the sum and stay tuned, because at the end of this sum, I'm going to give you some tips about studying the theorems, and which theorems would I say in my experience are kind of more important to study than others. Now, I love these kind of sums because it's 5 score marks. If I look at the sum, there's nothing strange. There's nothing weird about this. They didn't ask it in a strange way. So it's a plain, straightforward theorem to study. So when I look at this sum, I'm always going to start any of my formal proofs. Okay? This is a formal proof. Why? Because they say prove the theorem. It's a formal proof, so you have to prove it in a formal way. You can't just prove it in your own way. There are 2 ways of proving this theorem, and I'm going to use the way that is more comfortable for me. So the first way that I always love to do is write out given RTP, construction, and proof. So when I look at this, ladies and gentlemen, any of the theorems are going to have these 4 parts. And because it is a formal proof, you have to give those headings. Let's start with what was given to me. I was given a circle with a center O and a tangent KFC to the circle. RTP, ready to be proven. In other words, what do I need to prove? I need to prove angle DFK equal to angle E. I get that from what they are asking of me. But for me to formally prove this, ladies and gents, I must do construction. It's not that I always have to, but most theorems require formal constructions. So what am I going to draw? I'm going to draw the diameter, FOP, and then connect PD. Okay, it's not on the sketch, so I'm going to put it in there. So what is going to be my strategy? I love to start with what do I want to prove? DFK. Let's make that angle KFD or DFK equal to X, simply for the ease of use. So in other words, we want to actually now prove that both of these are equal to X. If I can prove that, then I've proved my theorem. So first of all, let's mine the information. I have a diameter, okay? So angle OFK is a diameter, and therefore it's a radius, and it must be perpendicular to the tangent. The same is then that angle PFD, or let's say DFO, is 90 degrees minus X. Okay, I hope that you understand that, because the X plus that angle must give me 90. Therefore, that angle is 90 minus X. Secondly, I'm going to say angle D, the whole angle D is 90 degrees because of angles in a semicircle. Once I have that, I can go to my triangle and say, well, angle P is equal to interior angles of, is equal to X because of interior angles of a triangle. Okay. Or am I going maybe a little bit fast? Let me just write that out a little bit by little bit. Angle P plus angle D plus angle DFO is equal to 180 degrees. So angle P, I don't know. I'm trying to find it. So angle P plus angle D is 90. And angle DFO is 90 degrees minus x. And this must add up to 180. So on the left-hand side, I'm sitting with angle P plus 180 minus x, and this must equal to 180. Therefore, if I solve for angle P, the answer is x. Again, because I'm going to subtract 180 there, and I'm going to add x, and I'm going to do the same on the right, so I'm going to subtract 180, and I'm going to add x. So this means angle P is x. But now what do I know about angle P? Angle P is actually equal to angle E because of angles in the same segment. But now look at this. Angle E is there for x, which means those two are the same. Therefore, angle DFK is equal to angle E because of they're both equal to x. So ladies and gents, how do I study this? And now I've thought about this long and hard, and let me quickly explain my logic. How I love to think about formal proofs is to break them up into smaller bite-sized chunks. So I'm just going to erase this on the sketch for now, and I'm going to explain to you my bite-sized chunks. So first of all, I'm going to go and say, well, once I've constructed my diameter, what am I actually doing? I'm first of all getting that angle there equal to that angle there. But how do I do that? Well, I've got 90 degrees there, and I've got 90 degrees there. Okay? And then after that, I'm moving over to getting those two equal because it is a cyclic quad. So what I love to do is take a big theorem and break it into smaller chunks. What am I doing? Why am I doing it? I'm not just sitting like trying to memorize this word for word for word for word. I'm just trying to see a strategy. Once I understand the strategy, it's actually not that difficult. So this, as us, consists of basically three parts. There's part, or let's say 4 parts. Number 1 is your top part. What do I have? What do I want to prove? And then, what do I need to draw? Number 2, in this theorem, is that part there, where I'm working with a tangent and the radius. The next part is that part there, part 3, where I'm actually working to get a value for angle P in terms of x. And then I've got the 4th part, which is angle E and angle P being the same. Look at how easy it then actually is. So don't just go and memorize this. Go and find the strategy for the formal proof. But how many formal proofs do I have to study? Well, in grade 11, there's 4, 5 proofs that you need to study. But not all of them can I say are equally important. What do I mean by that? I'm meaning they're not asked as often. The first one, which is the one we just proved, is Theorem 9. That is the one asked most often. But now let me give you a nice little tip. If they ask you a formal proof in a matric exam, you know that they're going to use that theorem in the rest of the sum. So if they ask you some theory question, they are going to expect you to use it in the rest of the sum. Interesting little tip. You're going to see that in the next video when we go to 11.2. Once you've memorized Theorem 9, I would then go and say, well, go and do Theorem 5, that the opposite angles of a cyclic quad adds up to 180 degrees. Okay? If you have time left over for studying your grade 11 theorems, then you go and do Theorem 1, which is the line from the center being perpendicular to the chord and vice versa. And last but not least, Theorem 2, which is the angle at the center equal twice the angle at circumference. And the special case. Remember that special case we used in the previous video, where we have this angle at the center and then it comes together somewhere else. That one there. Okay. That is still one that they can ask, but I'm saying it is almost for me less important. I'm saying that in inverted commas because they don't ask it often. But I encourage you to go through them in any case before the finals because you don't know what you're going to get. 5 marks, 6 marks is a lot of marks. That's 4% if you look at 6 marks. 4%. That's a difference between 68 and 72. The difference between 81 and 85. 79 and 83. So go and spend some time because you know you're going to get one of these. In grade 12, there's a bit more of it. You know, the formal proofs in grade 12, ooh, they're a bit more interesting. So I want to encourage you to go and also study the grade 12, especially Theorem 1, okay? Which is if there's a parallel side, then it divides the two sides of the triangle proportionally. That one I have seen them asked in the exam. But also they could ask you Theorem 2, which is if the angles are equiangular, if the corresponding angles are the same, then the triangles are similar, and also that there is that there's ratio that exists between the corresponding sides. There is also a little one that I haven't seen them asked often. I haven't seen them ask it in the past 5 to 10 years, to be very honest with you, which is the theorem of Pythagoras by using similarity. Interestingly enough, there are, last time I heard, there are more than 10 formal proofs for the theorem of Pythagoras, which is really awesome. And the one that's part of your grade 12 curriculum is using similarity to prove the theorem of Pythagoras. Oh my goodness. 15 minutes of pure theory. If your teacher did not do the theory with you, because I know some teachers decide to not do it, I encourage you to go and look up this lady that's written in the block here. Okay, let me just write it in a smaller one there. Jessica Ballantyne. Okay, Jessica Ballantyne brought a whole series of videos about grade 11 and 12 Euclidean geometry. And those videos have been watched thousands upon thousands of times. And I even use it in my videos. So big shout out to Jessica if you ever get to see one of my videos. You've always been an amazing inspiration for me and creating my videos. And I actually use her videos in my class to teach my guys this because she does it so well. If you have the time before the finals, go and watch these videos. She explains it amazingly. And then also, she goes on and does practical examples. Ladies and gents, this is Sarel van Grennen, aka Mr. VG, and I'm signing out for this video. Please tune into the next video where we are actually going to do the big question, 11.2. And I'm going to work through it with you as our last video in this series. So have an amazingly beautiful rest of your day. Keep well. Cheers.